Hello, welcome to the one more hands-on session on word embeddings. Until now, we have explored various factors and performance of word vectors, and we have experimented with some features of word embeddings, both word to vec and also the glow word embeddings. But we didn't use to perform any ML task, right? So in this session, I am going to use those word embeddings in order to actually perform the text classification task. So these word embeddings can be applied to various ML tasks such as text classification, text clustering, topic modeling, etc. But it's not limited to a certain kind of application. But in this session, I'm going to explain the application of these word embeddings in a text classification task. So what is text classification? It is a process of classifying a group of text into a particular label or particular category. So given text, we have a label associated with it. So we have to build a predictive model which can classify the text to the particular label. So that's our major intention of text classification. So in this session, I am going to walk you through the step-by-step hands-on procedure in order to perform the text classification task using word embeddings. So before that, I will just overview the type of data or the input data which I have used in order to build the predictive model. So let's just have a overview on that. So this is how our data looks. So the very first thing is the label or category where this entire text belongs to. So it's basically a tab separated values. So the first thing, the first word would be the label, and the text which is coming after a tab will be the associated sentence to that particular label. So we have similar kind of data. See, we can have a look at it as well. So we have a label and a sentence associated with that label. So this is a hand tagged data available in the Wikipedia. So I will be providing you this data as well at the end of the session. So since we have looked our data how it looks like, so now it's time to separate that data into label and associated sentence. So what we will do, we will first import the necessary libraries, that is NLTK corpus for the stop word removal and punctuation removal, and also we will also import the word to vec model and also the glow model in order to perform or apply those word embeddings to the text classification. So for that I am going to import the word to vec word embedding from genism.models. So now it's time to load the training and test data. So both this training and test data is same, like which I have showed just now. Only thing is the number of sentences or the number of samples are few in the test data set, whereas there are more sentences in the trained data sets. The rest everything, the structure and sentences, labels, everything remains the same. So now what we will do, we will prepare our training data. So for that, what I have done, I have declared two variables x and y with two different lists. Now I am going to iterate over this training data, and I am going to split that based on the tab, so that I can pop out the label associated with this, and I am going to associate that label in the new variable called label, and a particular sentence associated with that label in this new variable called text. So again, I am going to split this text into each individual words or individual tokens, because in order to supply this data into the word embedding, we have to convert that into word vectors, right? So for that I am going to split those words into tokens, and also we will perform another activity like removing of stop words. So for that purpose also we need this text splitting. So I am just splitting those text and appending back into the X list. So this is how I am going to create a training data set. Similarly, I have created the test data set as well. So the X test and Y test. So the variable X and X test indicates the sentences, whereas the Y and y test variables indicates the label associated with it. So we will also have a look of number of samples present in the training data. So here you could see the number of training samples are 5485, whereas the number of test samples are 2189. So we can also have a look at the shape of it. So x shape is nothing but only the sentences, so that's why it has 5485. Also the x text would be the 2189. Now we will have a look of how many labels are actually present in our data set. So for that, what I am going to do, I am using this unique function from the NumPy library. So I will use this and I am pass this y variable and have a look at what are all the unique labels available with us. So we have 1 2 3 4 5 6 7 8. So we have 8 unique labels available with this. So the entire text corpora will be consisting of sentences belonging to either of these 8 labels. So what we will do, we will first use a basic classification model, that is navy bias. So which is one of the most popular and most widely used text classification model. So before directly jumping into the word embeddings, what we will do, we will just perform this task using navy bias classifier. So even in the navy bias, we have two different navy bias models. One is single class navy bias model, and we have another navy bias called multi-class navy bias classifier. So what we will do, I will first jump with a single class navy bias classifier. What I am going to do, I am going to take the x data and I am going to concatenate all the words into a single sentence. Even I am doing the same for the test data as well. Now it's time to convert that textual data into numerical form, right? So for that, what I am going to do, I am going to use this frequency based vectorizer, that is count vectorizer. What it will do, it will just give me the frequency of each word. So it will just associate that word along with its frequency. So by this I am going to convert the textual data into numerical data. Meanwhile, I am also removing the stop words in this. So this is how I am going to create the vector. So this vector will be, this count vectorizer will convert the textual data into vector form, vectorical form. So also I have given one more variable called max feature. So I am going to derive 5000 different features associated with the text. So we can set this variable to any number, but now I have just for a training purpose or a demo purpose, so I have just set it as a 5000 variables. So now I have created this vectorizer, and now I am going to fit that on the our training data or x text or the x variable. So after fitting on it, so I am transforming that vectorizer again. So for that I am going to use vectorize.transform the text test data again. So now it's time to apply the similar transformation on the test data as well, because the formats of test and train data should be same. So I am going to x test transform equals to vectorizer.transform x test text data. So now it's ready. Just have a look of how many features are, or how the text is converted into a numerical form. So here you could see the vectorized form of the input textual data. So the champion word has occurred with a frequency of 759. Similarly, the word products as well. Now we'll jump into building of unique class or a simple Bernoulli navy bias classifier. So we'll start with this. So I have imported the two metrics, like metrics from the sklearn.metrics, that is accuracy. So I am going to like evaluate my navy bias classifier based on the accuracy of the training and testing. So I will also import this Bernoulli's navy bias classifier from sklearn.navy bias. So I am going to initialize this in BNB, Bernoulli's navy bias classifier, and I am going to fit that data now. So I am going to pass the transformed or the vectorized data as a x value and y value, that is label. So this is a training data, right? So I'm not going to pass the test rate. So I'm going to train the model first. So bnb.fit will take two inputs, that is the input text and a label. So that's what I'm going to do. So I have passed the entire transformed or the vectorized test train data along with the label. Now in order to predict the same, I am going to use the I am going to perform the classification task. So for that I am going to use this predict function available with the Bernoulli's naive Bayes classifier. So I have passed that predict option or the predict function along with that train data. So you can just see the training and test accuracy of the naive Bayes classifier. Here you could see the training accuracy is 0.87, whereas the test accuracy has come out to be 0.86. But is it the best values we are available with it? No, right? So we can perform better operation or better techniques in order to attain a more accuracy. So for that, what we are going to do, we are going to use another form of naive Bayes classifier, that is multinomial or multi-class naive Bayes classifier. The rest every steps will be remains the same. Only the thing is, like I'm going to import this multinomial naive Bayes classifier and I am going to assign with the M and B. Now I am going to fit the same extrain transform data along with the label to this multinomial naive Bayes classifier, and now I am going to use this predict option for both X and train data. Now we will test the accuracy of the both train and test data. You can just see that the training accuracy has improved from 0.87 to 0.96, and also the test accuracy has increased from 0.86 to 0.96. So this multi-class or multinomial naive Bayes classifier has improved the accuracy, right? But is this the best accuracy what we can achieve? No, right? So we can perform another techniques or other methods in order to improve this accuracy. So what we are going to do, we are going to use our own concepts of word embeddings, that is word to vec or the glow word embeddings, in order to predict the or perform the similar text classification activity, and let us see whether the word embeddings could outreach or outbound these accuracy values from the normal or a basic multinomial naive Bayes classifier.